morning. Welcome back to the course, practitioner's course in descriptive, predictive and prescriptive analytics. So, till now you must be very clear what are distributions, what is normal distribution, which is the main distribution that can be said to be the building block of all other distributions. So, you have gone through hypothesis testing, T-test. Today in this lecture I will discuss ANOVA, analysis of variance. This can be said to be backbone of analytics if we are working in predictive analytics here. So, the contents will go like this. What is analysis of variance? ANOVA. Why do we need ANOVA? How to conduct ANOVA? I will do this with help of an example here. Then we will see certain assumptions which are taken in ANOVA. Then we will see analysis of covariance. We will see the difference between ANOVA and ANCOVA and certain issues in interpretation. Also, I will give the term MANOVA. So, what is analysis of variance? Analysis of variance or ANOVA is a statistical technique that is used to see if there exist significant differences between means of 3 or more independent or unrelated groups. 3 or more independent or unrelated groups. So, you know this is a distribution by this shape. The first thing that comes into your mind is normal distribution. This is my normal distribution for the whole population. If I divide my population into groups, I have put here 3 or more groups. I divide into 3 groups. Let me say there are 3 groups, 3 small groups, and let me say there are n elements in the population and n1 here, n2 here and n3 here. Then n is equal to n1 plus n2 plus n3. That means these 3 groups form the whole population. Now, let me say this group has mean x1 bar, group 1 bar, group 2 bar and group 3 bar. The mean for whole population is x bar. Now, what would ANOVA test? ANOVA would test at, is the mean similar? Do these groups belong to the same population or have they come from the different population? These things would be tested in ANOVA. Now, let me try to represent this visually here. If this is my full population and 3 groups are placed, let me take a different color. 3 groups are placed like this. This is the total mean, group 1, group 2 and let me say group 3 here. Now, we can see there is a difference between the means of these groups. This is the difference. This is the difference in the means. This is the difference in the means. Now, is this difference significant? This is the question. Is the difference between means significant? This is a question. Let me put in a different way here. So, let me say one of my group here is lying outside this population. this is a group X3, though there is some overlapping, but it is lying outside this population. That means this difference is significant, and we put the level of significance as well. So, is it significant at a specific significance level? So, you know what is significance level? If I put 0.25 and 0.25 here, the area here, if it is 0.95, the remaining area, this means it is at 5% significant level or 95% confidence level, CL, this is 5% significance level. So, is this mean away from or falling outside my population mean? That means there exists a difference of means, significant difference of means, and do these means lie inside? So, let me take one more example here. So, let us say I have x2 here and x3 here, however, x1 is lying inside, this is x1 bar, here I have x1 bar, this is x2 bar, this is x3 bar. In this case, x2 bar and x3 bar has a significant difference from x bar. So, these are lying outside, x2 and x3, if I put significant level here. So, means are in different locations here, x3 and x2. x1 is quite close to the population mean, but the overall relative mean is away from x2 and x3 group means here. So, the hypothesis in ANOVA is put like H naught, null hypothesis here is mean 1 is equal to mean 2 is equal to mean 3. Please remember, we are not saying that they are exactly equal, that means the means are similar, they belong to same population. Exactly equal means, for example, this mean is 9.2, this would also be 9.2, this means also be 9.2. This is not the case. If this mean is suppose 10, this 95% limit is, let me say, 9.1, and here I have 10.9 as my 95% interval limits here. So, that means this mean is between 10 and 10.9, between 10 and 10.9, and this mean x3 bar is less than 9.1. In this case, x2 bar is greater than 10.9, which is my limits here, right hand side and left hand side limits. So, we can see here is x1 and x2 and x3 group means we can compare them individually using Ttest. Ttest hypothesis may be stated that for comparing x1 and x2, he can say x1 bar is equal to x2 bar, or second hypothesis may be x2 bar is equal to x3 bar, third hypothesis may be x3 bar is equal to x1 bar. So, all these three means are compared individually, and if I say I have 95% confidence level here, 95% confidence level here and 95% confidence level here, overall population confidence level would be compounded. compounded error I could put here. That would be 0.95 into 0.95 into 0.95, which comes down to 0.86 something. So, 1 minus 0.86, which is equal to 0.14, becomes my significant level here. So, we can use ANOVA to test all these three groups together, three or more or multiple groups can be tested together. So, this is what ANOVA would do. So, you know what is variance? Variance is the spread. This spread from this point to this point is variance. So, let me say my three small groups which I am taking here have larger variance. Let me say this variance is large and this variance is again large and this variance is again. So, where does this bring us to? If my small groups, the groups are small, if this spread is larger, that is the variance is larger, it is more likely to be within the group. That is the overlap would be higher. If this variance of small groups, I am talking about the three small groups I have, if the variance of small group is smaller and they are away from my population mean, that means there is a significant difference. And if this variance is large, that is trying to bring it closer, trying to bring it a little overlapped to my population mean here. So, if this variance is large, so this variance that is in my groups, or better to say within my groups, is my internal spread, or that is known as within variance. And for the whole population, this difference, the variance of the groups from the population, this difference is known as between variance. Between the population mean and my group. So, this is also between, this is also between, this is within. So, overall mean has distances from my groups and my groups individually also have spread. So, this variability between variance is also known as explained variance. This within variance is unexplained. So, the whole population is not able to explain this. So, we call this as error. So, if you recall, we had SS between and SS error in our regression. So, these terms we will use here to see how does ANOVA work. So, this between and within variance tells us about the significance of difference. So, this is distance from population mean to make it clear again, this is within group or internal variance. So, there can be certain cases here. So, we know that variance between and variance within, variance between plus variance within brings our total variance in the data. So, this is explained by the data, this is within group, this is not explained by the data. So, if the variability between the means, that is distance between the overall mean that I have put in a numerator here, I will put this as a term and put F statistic here. So, I am not putting equal to sign here, I am saying F statistic is proportional to this relation. What is it exactly equal to? We will see. So, there can be certain cases here when variance between, that is numerator is large and denominator is small. So, there can be three cases. One is the numerator is large, denominator is small. Other thing I can say, these are similar. Third case is this is small and this is large. And remember, what was our hypothesis here? That these means are equal. So, this hypothesis will be rejected if the means are not similar. So, if the means are not similar, what is this case? This case is variance between, that is this distance. The distance between the group means and the population means is large, is very large. That means these groups are located far away from my population mean. So, what does that do? That makes it not to fall in the population. So, in this case, the null hypothesis of similar means is rejected. So, what we will see here, we reject the null hypothesis provided at least one group falls outside, and we have small or narrow within group means here. So, if they are similar, similar means if the case is like this. So, what is there in this case? This is my population mean if I say, and I have three groups here. This is, let me say, group 1, group 2 and group 3. So, what we can see here is the means are very much close. That means we fail to reject the null hypothesis. Do not reject H naught, and we can see overlapping here. And if the population mean is close to the group means, so this is case 3 where the denominator is small. That means the population mean is not very much distant apart from the group means. I will put group 1, group 2, and group 3 here. In this case, you can see the dark green, blue and light green, there are 3 groups with means x1 bar, x2 bar and x3 bar, the small distances from the population mean. However, their within group mean is large. In the previous case, I had the similar means. This is both similar, the spread and the spread for both the population and the distances are all similar. So, in the third case also we do not reject H naught. So, what would be the case 1? Case 1 is population. I am having the narrow or small within group variances. In this case, within group variances are small. This is small, however, this is large. So, this is my case 1. Case 1, provided this one of the group is outlier. This is outlier. So, these are my 3 cases. So, my H naught was all the variances are equal and a test ANOVA would be conducted for more than 2 populations. So, ANOVA should have an independent variable that is categorical or metric. However, the dependent variable is metric. In business terms, if this variable is metric, we call the term analysis of covariance. So, next terms, why do we need ANOVA? Earlier what we did, we had Ttest. Ttest could compare only 2 groups. If groups are more than 2, number 1, we have subgroups, that is internal variance also exists, and we will see that interaction between the groups, that is one group is interacting with the other group as well. For instance, if I am saying my metric variable is the final marks of the student and my variables are, let me say, boys and girls is a categorical variable, and metric variable here will be the time they spent on study, and one of the variable may be how much time they watch TV. Okay. If I say marks, okay, this is my dependent variable. Okay, then I say my students, I divide this into boys and girls. So this is a categorical variable. That has two levels. One is boys, second is girls. So next is let me say there are variables. This is variable A, variable B. These variables are also known as factors. Okay. Time spent on study, time spent on watching TV. So there might exist some interaction between the time spent on study and time spent on watching TV. So ANOVA, without interaction, consider that there is no relation between these two. However, if he spends more time on study, he would spend less time on watching TV. So there might exist an interaction here. So ANOVA is used to compare more than two populations, and subgroups internal variance is also considered there, and we can also see the interactions. So all these things Ttest cannot. Ttest has a limited application. So next comes the relationship amongst the test. So you have seen Ttest, you have seen regression. Where did we do Ttest? When the dependent variable was a metric, that is it was in interval scale, and my independent variable was just variable. It may be metric, non-metric, that binary test was used, that was the Ttest. And if my independent variable is categorical, that is factorial, we used ANOVA technique. And if we have categorical as well as interval variable, that is metric as well as non-metric variables, here analysis of covariance is used. For instance, in this case analysis of covariance would be used. We have categorical variable as boys and girls, one categorical variable, that is the gender, and two non-categorical variables which are the metric variables, time spent on study, time spent on watching TV. So if both the variables, dependent variable and independent variables, both are metric or both are in interval scale, then we used regression. Okay. So if we have only one factor, we call it a one-way ANOVA. If we have more than one factors, we call it n-way ANOVA. So please keep this in mind, which test or which technique is applied and in which situation. So next is one-way analysis of variance. So one-way analysis of variance is a technique to test two or more variables and its influence on a single independent variable. We have one dependent variable and two or more independent variables. Okay. So there are certain terms that we will keep using. One is treatment. Treatment is a particular combination of factor levels or categories. For example, if I say if I made the categories boys and girls, and I have distributed the time into a ratio scale, if I say time from 0 to 5, 5 to 10 and so on up to 45 to 50, 10 different classes are there. So one category or one treatment would be boy who spends from 25 to 30 minutes. This is one treatment. Another treatment may be boy who spends 15 to 30 minutes, 15 to 20 minutes, that class. the class size is 5 minutes here, and it may be a girl who spends 0 to 5 minutes. That one set is my treatment here. It is a particular combination. Of factor levels. So, one-way analysis of variance involves only one categorical variable, that is a single factor. And in this ANOVA, a treatment is same as factor level. A treatment is same as factor level because we have only one factor. So, there may be certain examples of one-way ANOVA. For instance, do the various product segment differ in terms of their volume of product consumption, or what is the familiarity of the engineering students to NPTEL courses? Is it medium, low, high? So, in this case, their familiarity to NPTEL would be my variable, and its category would be medium, high or low. This is my one categorical variable. So, this is one-way ANOVA. So, I can put it here, an example. Familiarity with the NPTEL courses. Okay. So, this is my independent variable. That is, familiarity may be high, medium or low, and my dependent variable here might be the number of courses taken. If I am testing it in a specific demographic region, let me say in a specific state in Uttar Pradesh, or maybe you can say a specific part of the country. So, there are certain terms that we will use here in ANOVA. Number one is eta square. Eta square is the strength of effects of x, that is the independent variable here. Strength of the effects of x independent variable on y, that is measured by eta square, and its value varies between 0 and 1. Strength of effects of x on y. Now, F statistic is nothing, as we just discussed. It is the ratio between the variance between and variance within. So, in ANOVA terms, in an ANOVA table that we will just see, we have mean square between, that is mean square due to x, and mean square within, that is within group, that is due to error. So, what is mean square? It is the sum of squares that we did in the regression, sum of squares divided by their corresponding degrees of freedom. Next three terms are again SS between, SS within and SS total. SS total is equal to the total sum of squares, it is SS between plus SS within just recalling, and this is nothing but the variation between groups, that is also denoted by SSX. This is also denoted by SS error. So, we call them around groups, and this is among groups. So, next is how to conduct one-way analysis of variance. So, I will put a flow chart here or the steps here. First step is we identify the dependent variable and independent variable. So, please note, independent variable comes first, dependent variable is the result, is the response here. So, we need to identify which is the dependent variable that is coming because of the independent variable. So, second step is we need to decompose the total variation. We decompose into two components, between and within. Third step is we measure the effects. Effects of the independent variable on dependent variable here. Then we test the significance. And finally, we interpret the results. See, all these steps go in a progression, one after the other. So, I will take an example and try to use all these steps to explain how ANOVA works. So, first thing is identifying dependent and independent variable. We will see in the given table, the example which we will take here, what are independent and dependent variables. Decomposing the total variation is nothing. We say that SS total is equal to SS due to X, that is explained, plus SS due to error. So, this is decomposition here. So, SS between is the variation in the dependent variable that is related to the variation in the means of the categories of S, that is with the in these categories here. So, for this reason SS between is also denoted by SSX. SS error is the variation in Y related to the variation within each category of X. So, SS within is not accounted by X, so but it is within the category. So, therefore, it is known as SS error here. So, as we know that SSX, SS, I will put Y here, total is equal to SSX plus SS error. We saw these relations in regression. I am just recalling those. This is yi minus y bar whole square. I varies from 1 to capital N here. Okay. So, SSX was y j minus y bar whole square, and we multiply this by n, that is the group size. If we have number of groups and these are inputs, so what is the group size? This is my group size, in this case 1, 2, 3, 4 and 5, group size is 5. If I say I have these groups 1, 2, 3, there are 3 categories and this group size is n, and in this case this is for each group. J varies from 1 to C, here 1 to C is my 1, 2, C is my number of categories. Okay. Then SS error is within group for all the groups. So, within group would be Yij minus Y in that group, the mean of that group, the sum of squares for I varying from 1 to the group size, this is 1 to n, 1 to n, and j varies from 1 to number of categories here. So, we will use these relations, we will see how the calculation, how the mechanism of ANOVA work in the following example. So, with this I finished the part 1 of my analysis of variance session. So, I will come up with the second part where I will take an example and do the calculations to conduct an analysis of variance.